Question number 20 for the exam 2 review. We need to find the formula or the equation for each of these graphs that are given to us. So for this first one, for A, what we know is we're going from x equal 1 to 2, so that's a one step. It is an exponential, so our equation is going to look something like y equals ab to the x power. The way we find b, that's the ratio of the y coordinates going from one step to the other. Now if this was like 3 steps, then we would find the third root, but when it's just one step, 1 to 2, we're going to take 36 divided by 12, and that's going to give us the value of b. And if you take 36 divided by 12, you get 3. Okay. So now we've got our equation. We know it's going to be y equals a b. Fix that. We know what b is. 3 to the x. Now what we need is a is the starting value, so that is the coordinate here. We know that it's got an x coordinate of 0, but we don't know what the y coordinate is. We'll call it a for now. But we know the x is 0. We're trying to find what the y value would be. And what we can do, though, is we know if we step backward from step 1, that this ratio of 12 divided by a, that just like 36 divided by 12 was 3, 12 divided by a also has to be 3. So that is what will help us here. Multiply both sides by a, so we get 12 equals 3a, right? A and a divided by a cancels out, and then divide both sides by 3. We get that a is equal to 4. 4 is equal to a. So our equation is going to be y equals 4 times 3 to the x. We'll follow a similar procedure over here. Again, we take the second one, 3.2, and again our equation is going to be y equals a b to the x. B is going to be equal to 3.2 divided by 4. And so to do that, we'll use our calculator. 3.2 divided by 4, and it's 0.8. It's less than 1 because it's a decreasing exponential. So this is equal to 0.8. So far we know our equation is y equals a times 0.8, or just 0.8 to the x. To figure out a, we do the same thing. We notice we're here at 1. We're going to take a step back. So this point will be 0, comma a. And so what we know is that when we take 4 and divide it by a, that we also need to be equal to 0.8. Just like when we took the 3.2 divided by 4. So notice as you go back, it's the higher one. That's the bigger one, but the one further along. So the one that goes with 2 divided by the one that goes with 1. The one that goes with 1 divided by the one that goes with 0. So again, we multiply both sides by a, and we get a divided by a is 1. 4 equals 0.8 a. And then we're going to take 4 divided by 0.8. And we'll actually get a larger number, because when you're dividing by a decimal less than 1, you get a larger number. So what we found is that a equals 5. Okay, so our equation, our full equation, is going to be y equals 5 times 0.8 raised to the x. So that's how we do an exponential. The next two, let me clear these out. we're going to have a linear and a quadratic. So we'll deal with both of those. So linear gives us an equation y equals mx plus b. B is the value of the y-intercept. Again, if we kept going, it would be, I'm going to guess it's somewhere maybe around 7, maybe 8. But we won't guess it out. What we're going to do is we take two of the points. And you can take any of the 2 points. So I'll take these two since they're nice and close together. We want the rate of change from one point to the other. So we can see it's going downwards. It's going to be negative. You can also use the formula for slope. Right? The slope is equal to y2 minus y1 over x2 minus x1. So I'm going to do it both ways. So it's going to be, our slope will be 2 minus 5, those are the y values, over 2 minus 1, the x values. So we get negative 3 over positive 1. And we can see that's 1, 2, 3. So we're dropping 3 and running 1. So our equation becomes y equals negative 3x plus b. Now to figure out what b is, it'd be nice if we knew x and y, and we actually do. Any of these, we could take any of these 3 points. I'm going to go ahead and stick with this one, 1 and 5, because that makes it nice. If I plug in 1 for x and 5 for y, notice all that's left, the unknown is b, so I'll be able to solve. So that gives me 5 equals negative 3 times 1 is negative 3. Add 3 to both sides. And we get that 8 is what b is equal to. So our equation for this is going to be y equals the slope plus b, which is positive 8. That's the equation there. When we have a quadratic, we might remember that a quadratic formula, if we know the two x-intercepts, we get this formula. There's a c here. There's x minus the first intercept. I'll call it x1. And x minus the second one, we'll call it x2. So there's that formula we have. X1 is negative 5, x2 is negative 1. Those are the x coordinates. So we end up with c, or y equals c, x minus negative 5, so that's minus a negative 5 would make it a plus 5. And x minus a negative 1, negative, negative, make it a plus. Right? And so now to find c, we need a third point, and the nice one is to have the y-intercept, because when we plug in 0 for x, right, there's an x there, there's an x there, y is going to be equal to 5. That's what we get. So we'll work through that. 5 equals c. X is 0, so 0 plus 5 is 5. This x is 0. All the x's are 0, right? 0 plus 1 is 1. So we end up with 5 equals c times 5. To solve for c, divide both sides by 5. That cancels. That's 1. So c is equal to 5 divided by 5 is 1. So our equation is simply y equals c is 1. We have x plus 5 times x plus 1. Now, you might not see this on a multiple choice answer. What they'll probably give you is the FOILed out version. So x times x is x squared. X times 1 is plus 1x. 5 times x is plus 5x. And 5 times 1 is 5. So you'll see y equals x squared plus 6x, 1 plus 5, plus 5. So that's going to be the final answer for that one. Finding equations given a graph.